Okay, hopefully you got my other video and now you're going to watch this one during lunch today. Hopefully this helped you out. So I worked it out in front of one of my classes since it was already, I was stuck teaching. But anyways, without talking too much, the first thing I want to make sure we understand is we're always going to factor whenever we're given weird rational functions like this. And hopefully again you know the X method. And using the X method, we're able to get it to be x plus 2, x plus 3 over x plus 2, x minus 1. Now, notice that the x plus 2's here will simplify, right? I can cancel out x plus 2 over x plus 2. So whenever you simplify something, that's your whole. So therefore, I now know, you see, that I have a whole at x equals negative 2. Because negative 2 plus 2 is 0, right? Now what? Let me clean this up here. It's kind of tough doing it when I already did the work. So hopefully this is all making sense so far. So now what? Well, the next thing is, now that we know we have a whole at negative 2, what's remaining here, this right here, is going to help us solve a few things. For example, I know whatever makes the denominator 0 is going to be a vertical asymptote. So x equals 1, because 1 minus 1 is 0, is going to be a vertical asymptote. So let's make note of that. So we now know that x equals 1 is a vertical asymptote. And then I'm going to, of course, graph all of this together at one time here once I got everything answered here. What about the horizontal asymptote? Well, that's when, well, actually, that's the tougher one, right? Let's talk about that here. So to find the horizontal asymptote, okay, what we're going to do here is we'll just look at the original function, and let's talk about this actually. Let me go to a blank page. Notice our function is an x squared with something over x squared with something else, right? And so this right here will help determine my horizontal asymptotes. For example, if this was a higher power, so I had an x3 over x squared, then that means we would have no horizontal asymptotes because it's just going to go to infinity. Because the numerator is just going to keep getting bigger than the denominator, it's just going to keep going on forever, ever to infinity, you see? If, however, it's x squared over just an x and something, well, because the bigger power now is in the numerator, oh, sorry, I already discussed that. That would be no asymptote again. Let's say in the denominator, it's actually x cubed with the numerator being x squared. So in this case now, we know that the 3 power, the bigger power, whenever the bigger power is in the denominator, you see, it's going to always drive it to 0. Because if the denominator is big, right, it's going to just make, it's like a fraction. It's going to get closer and closer to 0, see? So whenever the bottom exponent, leading power, is the biggest, bigger than the top leading one, we know that y equals 0. The x-axis is going to be my horizontal asymptote. Now, in our case, though, what we have here is a tie. We have an x squared over an x squared. So therefore, if I simplify x squared over x squared, so I got actually interrupted by Mr. Cal there. He was doing me a favor. But anyways, so whenever there's a tie in power, basically you just simplify it. So what's x squared over x squared? That simplifies to 1, right? Now let's say this was 3x squared over 4x squared. That would simplify to 3/4. So whatever it simplifies to in this case is going to be your horizontal asymptote. So let's put it all together so far. What we hopefully understand, hopefully I've done a decent job with this so far, is we know that x equals negative 2 as a whole because x plus 2 over x plus 2 simplifies, right? And then we had x equals 1 as a vertical asymptote because the denominator was an x minus 1. And whenever we divide by 0, it goes to infinity. We just figured out because of x squared over x squared, that simplifies to 1. So we have a horizontal asymptote at 1. Now, what about the x-intercept? Well, basically, you just plug in 0 for y and you solve it. Well, if you think about it, that, I'm trying to clean up my markings here. If you think about it, that just means whatever makes the numerator 0, right? So x equals negative 3 makes the whole thing go to 0. So that's my x-intercept, because y would become 0 when x is negative 3. Now, for the other intercept, that's real simple. We just plug in 0. So in other words, if you look here, follow the green here. When I plug in 0 there for x, what happens? I get this here, right? I get 2 times 3 over 2 times negative 1. That's 6 over negative 2, which is negative 3. So now I'm going to put all that information together. Again, the information I'm talking about is all of this here. Okay? I'm now going to use this and do the graph. So here we go. Let's find the graph here. Here it is. So notice here I did my y equals 1 horizontal asymptotes. Right here in purple, I did my vertical asymptotes at x equals 1, right? And then I plotted my y-intercept there at negative 3, 0, my x-intercept at negative 3, 0, and my y-intercept happened to be negative 3, so 0, negative 3 right there. And then I knew that basically the graph had to do this towards the horizontal asymptote and go down to this towards my vertical asymptote here. And by symmetry, it's going to match up over here as well. And hopefully that helped you with this problem. Sorry if I feel like I'm rushing because I'm trying my best, even though I was just so tired last night that I honestly left my iPad in the car. I didn't even bring it inside. So hopefully these videos help you out. And just let me know if you want me to do the other page, okay? I'll be looking at your emails throughout the day, but hopefully you'll study these two and this will be enough to help you get through what you need to get through, all right? But it's always good to see you, and I hope to see you again soon.